Okay, let's do a quick walkthrough on the simulation here in OpenRocket. This was a off-the-shelf Estes model kit, the Estes Centauri. I didn't have to design anything here, so this is just kind of as is. But what we are interested in is looking at the motors and the flight simulation. So if you see here, I put in a half A motor and a C65. The C65 is actually what was recommended by Estes on one of their flights. And this is just to kind of show you here in the simulation what differences we get. So let's run both of these here. So you can see on that half A, now it wasn't recommended to fly that by Estes. This would just be, oh, hey, there's a motor here in a box, or I have an extra one. Does it work for this rocket? Should I fly it? So the first thing you want to look at here is the apogee. It's only going to go 16 feet. Not very high, not worth the effort, and most likely unsafe to only fly at that high. You would take, let's see here, optimum delay, right, is going to be 0.9 seconds, and that's actually got a 2-second delay. And most likely what you would have is that rocket falling back to the ground, that 16 feet, before that ejection charge even fires. So it's already sitting on the ground, and then it blows up. You can see the total flight time, right, is only 2 seconds. So not a good height, not something you want to do. Another thing that's not as obvious is the velocity off the launch rod. So if you go in here and you click Edit Simulation, this is important to note. So you want to put in the length of your launch rod, what angle. You don't necessarily have to do the latitude, longitude, altitude. Probably is beneficial, especially here in Colorado where you're most likely a mile or higher. But this is key. So if you're doing off a launch rod, it's most likely only going to be about 36 inches. You could measure your kit. The goal here, though, right, is to hopefully be launching off a rail system that's going to be about 6 to 8 feet. But you can see that's where I put it in. So 8.92 meters per second. It's pretty slow off the launch rod. And what you have is, if it's too slow off the rod and you have a little bit of wind, or the rocket wasn't stable, or it wants to pivot on the last launch lug, your rocket can kind of veer off in a direction you weren't expecting it to or planning it to. And again, with this one only having an apogee of 16 feet, this is all happening way too low, way too slow. You run a pretty good chance of that rocket heading off into your crowd or towards yourself. About 13 meters per second and above becomes very safe, very stable. You can launch a little slower, probably down to, I would say, 10 meters per second at the minimum. 11 would be a safer minimum. But you can see right here at 13, we're sitting pretty with the velocity off the launch rod. We're going to go about 450 feet. That's perfect. It's telling you here an optimum delay would be about 3.7 seconds, and we have a 5. Estes motors, you don't get to dial that in very much, but that's fine. So these are some key things that you want to look at before you actually go launch your rocket, is make sure that you're going to have a safe maximum altitude and apogee, and that you're going to have a safe velocity off the rod. Some people just kind of know by their impulse that they'll be fine. But if you're new and just getting into this, if you haven't launched a bunch of different class motors, definitely come in here and use OpenRocket. Double check what you want to run, and make sure that your flight's going to be safe. The other thing you can always do too is when you after you run that simulation and you go to edit, if you want to, it's not incredibly intuitive, but if you come back over here, you can actually go to plot. You can tell it what you want to see, and then go ahead and hit plot again, and it'll kind of give you that drawing. So you can see here that it's only going up. It looks like a pretty curve, but it's only going up 16 feet from launch, and it's going to land about 6.5 or so feet east. The one thing we did not put in here correctly was probably the wind. That's something that if you brought your laptop out to the field and you had a little anemometer, you could measure the wind, what direction it's coming from, input that in your simulation, and have a little bit better chance of this being more accurate. If you were launching really more mid-power, even up into high, this would be great because if you lost track of your rocket, and if you had correctly entered the wind, altitude, and a bunch of those other features, it might actually give you a pretty good direction to head in to find your rocket. You could match that up with what you could see. Did it look like it was going that direction? But say this was like 100 scale and it went 1,600 feet or something like that, and you lost track of it. If everything else was right, you might be able to scale this out, and you would understand. Okay, I'm gonna head east, or I'm gonna head this direction, and it's probably about this many feet, and kind of start your search from there if you lost track of it. But you can see here that is a nice curve. It's just this 16 feet, not very safe. Just for grins, we can pull up the other one as well. We can plot that. Bit more of a curve there, but again, 450 feet, coming back into the wind a little bit. But you can see safe distance away from where we launched it. Obviously, the wind here is carrying that quite a ways, but overall, pretty useful. Definitely check these out. Definitely be safe when you're launching. Again, double check your velocity off the rod and your apogee before you go waste motors and waste time setting everything up.